Hello everyone. I'm your instructor in General and Inorganic Chemistry. Before we proceed with our discussion of the types of chemical bonds and naming compounds, may I request everyone to kindly get first your periodic table of elements, a notebook, and a pen before we proceed with the discussion. Okay, 30 seconds will be given to you. Mm. Again, our discussion is all about the types of chemical bonds and naming compounds. But first, let us define what is chemical bonding. So when we say chemical bonding, it is a lasting attraction between atoms, ions, or molecules that enables the formation of chemical compounds. Remember that when we say atoms, ions, or molecules, two or more elements po dapat tayo, compound po dapat. Yan kaya nga tinawag na chemical compound. Compound is a combination of two or more elements. So note here is atoms will form chemical bonds with each other in order to fill their electron shells and gain stability. Some elements have atoms with ideal number of electrons needed by others. This makes certain pairs of elements more compatible for bonding. But remember, in chemical bonding, we have in the periodic table of elements, we have the group 18, which are the noble gases. We all know that the noble gases in the periodic table of elements are stable, and mostly the elements are hindi po sila pwede for chemical bonding. Later on, sasabihin ko lang po yung mga elements from the noble gases na pwede lang po natin i-consider for chemical bonding. So before I discuss the types of chemical bonds, let us first define the terms that will be the terms that you will encounter as we go on with our discussion. First, the electron shell. So when we say electron shells, every atom has a certain number of electrons, which orbit the nucleus in the electron cloud. These electrons orbit in different energy levels, which are known as electron shells. As we can see here in the image, at the right side of the definition, um, mali man siya sapagkat in the nucleus, we have only the proton and the neutron, and the electron should be in the, what we call this one, in the electron shells. But if we will see the image, ito pong mga circle po na ito na lumilibot or basta yung mga, ito pong circles na pinapalibutan yung nucleus po natin, ayan po yung sinasabi nating electron shells. Ito po sila. Ito po yung circles and that ito po yung tinatawag nating electron shells. Diyan po natin inilalagay yung mga negatively charged particles natin, which are the electrons po. So in the another term is the valence electrons. So when we say valence electrons, the electrons in the outermost shell of an atom are known as valence electrons. In the Lewis dot diagram to the left, you can see that beryllium has two valence electrons. Balikan po natin yung definition ni electron shell po natin. So these electrons orbit in different energy levels, which are known as electron shells. If the question is asking for the term, what I mean, kapag electron shells po kasi, lahat po ay isasama natin. the first electron shell, second electron shell. Pero when we say valence electrons po naman kasi or valence shell po, ito po yung sinasabi nating outermost. Ito lang po. The outermost electron shell of an atom, that is what we call the valence shell. Again, the outermost electron shell of an atom is what we call the valence shell. But if the question is asking for the electrons, the valence electrons po ang tawag doon. Remember that in the first electron shell po natin, it can accommodate maximum of 2 electrons only. In the second energy level or second electron shell, meron po tayong 8 electron shells. Sa pangatlo pong electron shell po natin, magiging 18 na po. It can accommodate 18 electrons po. Hanggang 18 electrons lang po tayo. And the fourth electron shells po natin, it can accommodate until 32 electrons. So, paano natin nakukuha yung formula ng electron shell po natin? We can use the formula 2 times, open and close parenthesis, n squared. Again, in getting the electrons, the number of electrons in the electron shell, kung pang ilan po siyang electron shell, we can use the formula 2 times n squared. So ano po ba magiging n po natin doon? Si n po ay isa-substitute po natin doon, kung pang ilang electron shell po ang hinahanap natin, i-substitute po natin doon kay n. For example, ang hinahanap po natin yung electrons na pwedeng i-accommodate ni second electron shell po natin. So, i-substitute natin si 2 doon kay n. So, 2 times 2 squared, the answer is 2 times 4, that is 8. Now, basta use the formula 2, open and close parenthesis, n squared in getting the number of electrons in that electron shell. Mas outermost shell of an atom are known as valence electrons. So may nabanggit dyan. In the Lewis dot diagram to the left, you can see that beryllium has 2 valence electrons. Ano po ba yung sinasabi nating Lewis dot diagram? Lewis dot diagrams is just the same with Lewis electron dot structure. We can represent elements using Lewis dot diagrams or Lewis electron dot structure, which visually emphasize those electrons over the others. If remember that in the Lewis dot diagram po, it is the element symbol po, hindi elements name ang gagamitin natin. Again, the element symbol. Ano po ba ang symbol ni beryllium natin? It is capital B and small letter E. Kaya element symbol lang pong ginamit natin dyan. So bakit kung papansinin natin si Lewis dot diagram, dalawa lang pong electrons na inilagay dyan. Kay beryllium po, ang atomic number niya ay 4. The atomic number of beryllium is 4. So, bakit naging dalawa siya, sir? Remember that binanggit ko kanina kay electron shells, the first electron shell can accommodate 2 electrons po. Since nagkaroon na siya ng dalawang electrons sa first electron shell natin, proceed na siya kay second electron shell. Since nag-accommodate na ng dalawang electrons, yung first electron shell natin, ang natitira na lang na electrons ilalagay natin for the second electron shell is 2. Gets? Kaya dalawa po ang electrons na inilagay or valence electrons na nilagay kay beryllium. Yes, in the Lewis electron dot structure, ang ilalagay lang po natin diyan na electrons are the valence electrons. Okay. So yeah, let us basta remember that the first shell can house 2 electrons and it must be full before any electrons can move to the next shells, which can house 8 electrons each. Nabanggit ngayon si 8 electrons po natin. Remember that we have the rule, which is what we call the octet rule. So when we see octet rule, partially filled electron shells are unstable. So all atoms want to fill their electron shells completely. Since most shells um, can hold 8 electrons, this phenomenon is known as the octet rule. Atoms fulfill the octet rule by forming bonds with other atoms. May nabanggit po dyan. Since most shells can hold 8 electrons, this phenomenon is known as the octet rule. Remember that the first electron shell can accommodate only 2 electrons. Pero nabanggit kay octet rule natin na most shells can hold 8 electrons. So, ang ibig sabihin lang po niyan, in the octet rule, the first electron shell, hindi po natin siya i-consider with the octet rule. So, i-consider lang natin for the octet rule is the second, third, fourth, and so on na electron shells. But remember, till 8 electrons lang po tayo. So, in the octet rule, nabalikan natin binanggit kung nakaraang lesson natin with the periodic trend. Remember that the noble gases or the group 18, which are the noble gases, of course, the group 18, which are the noble gases, some of the elements are stable and doesn't satisfy the octet rule because it is stable na. Meron na siyang 8 electrons in the outermost electron shell. But some of the elements like xenon and krypton can have chemical bonding with fluorine and other elements. So again, in the group 18, which are the noble gases, some of the elements, bilang lang po yung pwedeng apply for the octet rule. These are the elements xenon and krypton. Pero bilang lang po ulit yung pwedeng makipag-chemical bond sa kanya, which is the fluorine. Okay, here is a question to check your understanding. So to check your understanding, as an example, fluorine has 9 electrons and 7 in its outermost shell. It will need one more electron to fill its octet. So bakit 7 lang yung nasa outermost shell natin? And saan ulit nakuha yung 9 electrons natin? Remember that number of electrons is just the same or always equal to atomic number. Anong atomic number po ba ni fluorine natin? That is 9. So 9 electrons po meron kay fluorine. Pero remember, kailangan nyo munang punuin yung first electron shell natin. Ang maximum for first electron shell is 2 electrons. So since may 2 electrons na po sa first electron shell natin, meron pa tayong 9 minus 2, 7 na natitira. So yung 7, ilalagay natin siya sa outermost shell natin, which is the second electron shell. So remember that to satisfy the octet rule, it must be 8 electrons. Since 7 electrons ang meron sa outermost shell, nangangailangan pa siya ng isang electron to fill its octet. Nagets po ba? So let us proceed with the next question. How many electrons would carbon need to fill its octet? Gamitin po ulit ninyo yung periodic table of elements ninyo. Ano po ba ang atomic number ni carbon natin? That is 6. So the atomic number is always equal to the number of electrons po. So since 6 ang atomic number ni carbon, 6 din po ang electrons niya. Yung dalawa sa electrons ay mapupunta kay first electron shell. So yung natitirang 4 sa electrons ay ilalagay natin sa outermost electron shell natin. So since to satisfy or to fill the octet, to fill its octet, nangangailangan si carbon ng 4 to satisfy the octet rule. Again, since dalawa ang nilagay sa first electron shell, 6 minus 2, it is equal to 4 electrons po. So since si octet po kailangan ng 8 electrons to satisfy the rule, 8 minus 4, meron po tayong 4 electrons that the carbon need to fill its octet. So how many would sulfur need naman? Papansinin natin with sulfur. The sulfur, ang atomic number ni sulfur natin is 16. So paano kuhanin yung valence electron po niya or the electrons in the outermost shell? In the first electron shell po ni sulfur natin, gamitin natin yung image dito. So since meron na siyang dalawa dito kay sulfur, tapos the second electron shell can accommodate till 8 electrons po. So 2 dito sa first and 8 dito. 2 plus 8, we have now 10 electrons. So proceed na siya ngayon sa third electron shell natin. So since meron na pong 10 electrons both in the first and second electron shell, 16 minus 10, the answer is 6. So 6 electrons po ang natitira kay sulfur. But to satisfy the octet rule, 8 electrons po ulit. So 8 minus 6, nangangailangan po ngayon si sulfur ng dalawang electrons to fill its octet. And last question, xenon naman and xenon. Balikan natin yung binanggit ko kanina. Group 18, some of the elements in the group 18 which are the noble gases are stable and satisfy the octet rule except xenon and krypton. Bakit po? Because xenon and krypton can have chemical bonding with fluorine and other elements. Wag po natin yung kalimutan. Okay, I hope you understand the terms that you will need to that are applicable to our discussion about chemical bonding. So let us now proceed with the four types of chemical bonds. So we have the four types of chemical bonds. The first is ionic bond, second covalent bond, third metallic bond, and fourth hydrogen bond. So proceed tayo kay ionic bond natin. Let us define ionic bond. So an ionic bond, it is the electrostatic force of attraction between oppositely charged particles. It is formed when valence electrons are transferred from one atom, metals, to the other, nonmetals, to complete the outer electron shell. So in ionic bonding, to summarize, the definition, to summarize the definition of ionic bonding, it is the transferring of electrons. It is the transferring of electrons from metal to non-metal. Hindi po pwedeng transferring of electrons from non-metal to metal. It should be transferring of electrons from metal to non-metal only. So both of the elements become stable po. Bakit magiging stable yung dalawang elements po? Then, balikan muna natin yung definition natin na it is a form when valence, etc. Sa-isahin po natin siya. Nakabot itong word natin na metals. So metals will always lose their electrons to become positively charged ions called cations. Remember that. Bakit po natawag siyang cations? Since si metal po ay nag-lose, nagtanggal, nag-remove ng electrons, ano po ba ang ni-remove ni metal po? Electrons. Ano po ba si electrons? These are negatively charged particles. Since nagtanggal po siya ng negatively charged particles, it will become positively charged ions called cations. So always po, si metals ay cations. Always po yan. How about non-metals? Non-metals will always gain electrons to become negatively charged ions called anions. Since si non-metals po ay nag-gain or nag-accept ng negatively charged particle or electrons po, nag-gain po ang nag-accept, it will become more negatively charged ions, kaya tinawag po siyang anions. Okay, let us have an example of ionic bonding. Papansinin po ninyo with the atom 1 and atom 2, the atom 1 should be metal and the atom 2 should be non-metal. The metal transfer electrons in the non-metal. Papansinin po ninyo, yung isang electron po niya, since mapapansinin ninyo with the atom 2 or the non-metal, ilan po ba ang electrons na meron dyan? We have 7 electrons. Since 7 electrons po yan at nangangailangan siya ng isa para maging stable siya and to satisfy the octet rule, mangangailangan siya ng isang electron. Kaya si atom 1, which is the metal, magta-transfer po ng electron kay non-metal para maging stable siya and satisfy the octet rule. So, in ionic bonding, both elements become stable. Let us have another example here. The sodium and the chlorine. I have here the image. Kung papansinin po ninyo with the sodium, ano po ba ang atomic number ni sodium? 11 po. So since 11 po ang atomic number ni sodium, it should be 11 electrons. So bilangan po natin ang electrons ni sodium dyan. So we have 1, 2, 2 electrons sa first electron shell. 1, 3, 4, 5, 6, 7, 8, 9, 10. Meron siyang 8 electrons sa second electron shell. So 8 plus 2, we have 10 electrons. Now, since 11 ang atomic number niya or 11 ang electrons ni sodium, naglagay na siya or yung isang natitirang electron ay inilagay sa third electron shell. Pansinin naman natin ngayon si chlorine natin. With the chlorine, 2, since ang atomic number ni chlorine ay 17, sa 17 electrons po siya. The first electron shell can accommodate until 2 electrons. The second electron shell can accommodate 8 electrons. And since 17 po siya, 2 plus 8, 10, 17 minus 10, 7 electrons po ang ilalagay natin sa outermost electron shell niya. Remember again the octet rule. And to become, para yung atom ay maging stable, para si chlorine ay maging stable at masatisfy si octet rule po natin, mangangailangan siya ng isang electron. Kaya si sodium ay nag-transfer ng electron kay chlorine. Balikan natin yung definition niya. Since nag-remove or nag-lose ng electron si sodium and sodium is a metal, ayan po, si sodium ay metal and nag-lose siya ng electrons, tatawagin natin siyang cation. How about kay chlorine? Si chlorine ay isang non-metal. Si non-metal po natin or si chlorine to be specific, nag-accept ng electron, nag-gain ng electron. Since nag-gain po siya ng electrons, anion ang tawag natin kay non-metal. Nagets po ba? Palagi po si metal ay cation and si non-metal ay anion. Palagi pong ang magta-transfer ng electrons ay si metal to non-metal. But both of the elements become stable. So the sodium donates electron, and chlorine accepts electron. Let us proceed to another example, last example in ionic bonding. We have here the magnesium and the oxygen. Papansinin natin, with the magnesium, ano po ba ang atomic number ni magnesium po natin? We have 12. Okay, sa 12 po yan. 12 ang atomic number ni magnesium po. Since dalawa na po sa first electron shell and 8 po sa second electron shell, meron na po tayong 10. May natira po tayong dalawang electrons. So yung natirang dalawang electrons ay ilalagay natin sa outermost electron shell po natin or in the valence shell po. So dalawa ang nailagay dyan kay magnesium. How about oxygen? Since atomic number po ulit ni oxygen ay 8 and dalawa ang maximum number of electrons kay first electron shell. 8 minus 2, ang natitira po ay 6 electrons. So yung 6 electrons po natin ay ilalagay natin sa outermost electron shell or the valence shell. Kaya 6 po yan. Kung papansinin ninyo with the oxygen, since 6 electrons po yan, nangangailangan po ulit siya ng dalawang electrons to become stable and to fill its octet. Since ang nasa valence shell po ni magnesium ay dalawa, si magnesium which is a metal in classification, magta-transfer po ng dalawang electrons kay oxygen to become stable and to fill its octet. So ayan, kung papansinin po ninyo dito sa right side niya, bakit si magnesium ay naging 2 positive and si oxygen ay naging 2 negative? Since si magnesium ay nagtanggal, nag-remove ng electrons, naging 2 positive po siya. Mas naging positively charged ion po siya. So since si oxygen ay nag-accept ng dalawang electrons, since it is negatively charged ion, 2 negative po siya. Understood po sa first type of chemical bonding natin, which is the ionic bond. Okay, but before that, I will have my 30 seconds break for water break lang. Okay, let us now proceed with covalent bond. So when we say covalent bond, the chemical bond which is formed by a mutual sharing of electrons between nonmetals. This bond is formed between atoms that have similar electronegativities or the affinity or desire for electrons. So bakit meron nagkaroon ng sharing of electrons? Kung si ionic bond ay transferring of electrons from metal to non-metal, si covalent bond naman po ay sharing of electrons both non-metals po. So because both atoms have similar affinity for electrons and neither has a tendency to donate them, they share electrons to achieve to achieve to achieve octet configuration and become more stable po. Again, both atoms in the covalent bond, both non-metals have similar affinity for electrons and neither has a tendency to donate them, they share electrons to achieve octet rule and become more stable. So let us have an example for covalent bond. We have both chlorine atoms. Si chlorine ay isang nonmetal. They are both nonmetals. Kung papansinin ninyo, with the first chlorine atom, 7 valence electrons po ang meron sa kanya sa outermost shell po niya. At nangangailangan siya ng isa to satisfy the octet configuration. Papansin ulit natin si isang chlorine atom, the second chlorine atom, nangangailangan din siya ulit ng isang electron to satisfy the octet configuration. Kaya ang mangyayari, instead of transferring of electrons, nagkaroon po ng sharing of electrons. Itong electron niya, nag-share siya. At itong electron niya, nag-share din po siya kay first electron. So, kung papansin ninyo, ito po, ayan po siya, ganito po yan. So, since wala pong, neither has a tendency to donate them, both the chlorine atoms, ang nangyari po ay nag-sharean na lang po sila ng electrons. So, in the covalent bond, sharing of electrons between non-metals. Let us proceed to another slide. Baka itanong ninyo, in the covalent bond ba, pareho po ba dapat sila ng atom? For example, chlorine dito, chlorine din dito. So same element po palagi kapag covalent bond? No. So let us proceed to another example of covalent bond. So kung mapapansin po ninyo with here, it is H2O molecule which means it is a water. Kung mapapansin ninyo with hydrogen, remember that in hydrogen, hanggang dalawa to become stable, yung hydrogen natin, dapat dalawa ang electrons yan sa electrons sa valence shell po niya. And si oxygen po ay may 6 na electrons in the valence shell and neither has a tendency to donate them. Ngayon, since 'di ba ito si hydrogen nangangailangan lang din naman ng isa para maging stable. Tapos ito, dalawa kinakailangan niya. And ito, isa. So, ang nangyari, it is a sharing of electrons. Remember that hydrogen is a non-metal in classification. And oxygen is also a non-metal in classification. So, since both of the atoms or elements are non-metals in classification, it is the sharing of electrons. Now, nag-share po ng electron si hydrogen kay oxygen and nag-share din po ng electron yung second hydrogen atom natin. So since nangailangan to ng dalawa, may pinahiram siya. May pinahiram din siya. I mean, may shinare siya, may na-share din siyang electron. Nag-share din si oxygen ng isang electron sa second atom of hydrogen and nag-share din po siya ng electron kay first hydrogen atom. Kaya all of the elements become stable by the sharing of electrons. May po ba tayo doon? Okay, in the covalent bond, we have two types of the covalent bond, which are the polar covalent bond and non-polar covalent bond. Wait, check ko lang sa Facebook kung naka-live ako. Hirap na, hindi siya ma-record. Ayan. So yeah, in polar covalent bond, it results when electrons are unequally shared between atoms. Non-polar covalent bond naman ay result when electrons are more equally shared between atoms. So bakit po dito kay polar covalent bond natin ay unequally shared between atoms? The unequal sharing of electrons in polar covalent band is due to differences in the electronegativities of two atoms sharing the electrons po. Again, the unequal sharing of electrons is due to differences in the electronegativities of two atoms sharing the electrons po. Kaya kung papansinin natin, uh, differences between the polar and the non-polar covalent band po. Ayan po. With polar covalent band po is either non-metal or metalloid, and in polar covalent band, unequal sharing of electrons. And non-polar covalent band naman, it is equal sharing of electrons. So let us see kung ano po bang sinasabi natin. Yung ano po ba yung sinasabi kong electronegativity difference? Kung bakit siya naging polar, kung bakit din siya naging non-polar. So in electronegativity difference and the band types, when we say non-polar covalent band, the the difference in electronegativities of combining atoms, it should be 0 to 0.4. How about polar covalent band? In polar covalent band, the difference in electronegativities should be from 0.5 to 1.9. Hanggang 1.9 lang po siya. So sir, how about kapag naging 2.0 na po siya? Wala na po kay covalent band. It should be ionic band. So again, non-polar covalent, 0 to 0.4. Polar covalent band, it is 0.5 to 1.9. And in ionic, it is 2.0 to 4.0 in the difference in electronegativities when it is combined. So let us have the examples of polar covalent band. The first example of polar covalent band is hydrogen chloride. In hydrogen chloride, ano po ba si hydrogen natin? It is a non-metal. And si chlorine din po, it is a non-metal. So bakit siya sir na-categorize as polar covalent band? Let us use the electronegativities of each element. Ano po ba ang electronegativity ni chlorine? Yes, can you use your periodic table of elements? Ano po ba ang electronegativity value ni chlorine po? Meron tayong 3.0. And for hydrogen, we have 2.1 in electronegativity. So, hydrogen is 2.1 and chlorine 3.0. I-subtract po natin sila. 3.0 minus 2.1, that is 0.9. Since 0.9 po siya, saan natin siya kakategorize? It is polar covalent band. It is between 0.5 to 1.9. Let us have another example with the water. Hydrogen po ay 2.1 and si oxygen, ano po ang electronegativity value ni oxygen? 3.5. So 3.5 minus 2.1, ang electronegativity difference po ng dalawang atoms ay 1.4. So na-categorize po siya as polar covalent band. Let us have another example with methanol. Kung papansinin natin with the methanol, ang daming elements na na pinag-bond natin, na pinag-combine natin. We have the hydrogen, the carbon, and the oxygen. Pero paano din sir kuhanin yung electronegativity difference niya? Kailangan nating i-subtract si carbon kay hydrogen, carbon kay oxygen, plus oxygen to hydrogen. So yung tatlo po ba dapat makita nating differences in electronegativities para manawag siyang polar covalent band? No. If we will see the electronegativity value of the elements, si oxygen po ay ilan po ba, ano po ba ang electronegativity value ni oxygen po. That is 3.5. Si carbon ay 2.5. And si hydrogen ay 2.1. Since si oxygen po, it is a more negative than carbon and hydrogen, meaning it pulls shared electrons. So, ang ibig sabihin na po, mag-concentrate tayo kay oxygen, kung ano ang naband kay oxygen. So, the oxygen pulls shared electrons towards itself more strongly. The oxygen atoms bond with hydrogen and with carbon. So, ang kukunin lang po natin, again, since among the three elements, hydrogen, carbon, and oxygen, 3.5 po ang electronegativity value niya. So, dyan tayo mag-concentrate. And ang naban kay oxygen ay si hydrogen and si carbon. Dyan lang tayo mag-focus. So kung titignan natin ang electronegativity difference ni oxygen kay hydrogen, oxygen is 3.5 minus 2.1, that is 1.4. How about oxygen to carbon? 3.5 minus 2.5, that is 1.0. So, since ang electronegativity difference um, ng methanol po natin ay from 0.5 to 1.9, it is a polar covalent bond. Hydrogen is a nonmetal, carbon is a nonmetal, si oxygen also is a nonmetal, kaya polar covalent bond. And the last example for polar covalent bond is the ammonia. Ano po ba ang electronegativity value ni nitrogen po? That is 3.0. 3.0 minus 2.1, that is 0.9. Ayan, polar covalent bond because of the electronegativity difference. It should be 0.5 to 1.9. How about examples of non-polar covalent bond? So here are the examples of non-polar covalent bond. The first example, we have hydrogen, two atoms of hydrogen. Non-metal siya, non-metal din po siya. Ano po ba ang electronegativity value ni hydrogen po natin? We have 2.1. So 2.1 minus 2.1, that is 0. So non-polar covalent bond po siya. And equal sharing of electrons. How about the second example? Chlorine, both atoms of chlorine. Ano po ang electronegativity value ni chlorine? 3.0. 3.0 minus 3.0, that is 0. Kaya na-categorize po ulit siya with non-polar covalent bond. Last example, basta ganito po yan. Ang clue po palagi with non-polar covalent bond, mostly po paulit-ulit yung atom niya. Dalawang same atom or same element po ang pinag-bond natin. So last example in non-polar covalent bond is this one. So mapapansin po ninyo, with the last example of non-polar covalent bond, meron tayong CH4. Ano po ba si CH4 natin? What is CH4 again? That is methane. Again, when we say CH4, that is methane. Ano po ba si carbon natin? Please, pinagkaiba kasi with methane to methanol. With methanol kasi, it is COH po. Kasama si oxygen po with the methanol. But in methane, that is carbon bonded with 4 hydrogen atoms. So yeah, ano po ba ang electronegativity value ni carbon? 2.5. How about hydrogen? That is 2.1. So 2.5 minus 2.1, that is 0.4. So that is a non-polar covalent bond. Okay, so let us now proceed with metallic bond, the third type of the chemical bond. So when we say metallic bond, it results from the electrostatic attraction between metal cations and delocalized electrons. Metallic bonding occurs when a group of metal atoms share a cloud of valence electrons. So again, in ionic bonding, metal to nonmetal with covalent bond, both nonmetals, and with metallic bond occurs when a group of metal atoms share a cloud of valence electrons. To explain metallic bonding, let us have the examples with a group of sodium, magnesium, and aluminum. So sir, so baka itanong ninyo, anong pinagkaiba ni metallic bond with the other types of chemical bonding? Kung papansinin po kasi ninyo with the electrons, yan po, yung mga electrons po niya, yung mga electrons po in the metallic bond, electrons in metallic bonds are not bound to any specific atom, but are rather free to move. Kaya kung papansinin po ninyo, hindi po siya naka-attach with the with the sodium atom. Hindi po siya naka-attach. Ibig sabihin lang po, yung electrons are not bound to any specific atom, but are rather free to move. This is referred to as electron delocalization. Ayan, electron delocalization. Again, electrons in metallic bond are not bound to any specific atom, but are rather free to move. This is referred to as electrons delocalization. Okay, so ano po ba ang mostly ginagamit natin for metallic bonding? In the metallic bonding, meron na po tayong certain metal elements, certain elements that are metal in classification na i-consider natin for metallic bonding, which are the elements sodium, magnesium, aluminum, and also the copper and iron. Again, in metallic bonding, we will consider the elements sodium, magnesium, aluminum, and also copper and iron. Copper and iron. Okay, let us now proceed to the last type of chemical bond, which is the hydrogen bond. It is slide 3357. Malati na tayo. So hydrogen bond, it is a special kind of dipole-to-dipole force and one of the strongest types of IMFA. Ano po ba yung sinasabi nating IMFA? It stands for intermolecular forces of attraction. Ano po bang meron kay intermolecular forces of attraction? These are forces that exist between molecules determining many physical properties such as boiling point, melting point, and solubility. So balikan po natin. In the intermolecular forces of attraction po kasi meron tayo different types po. We have the London dispersion forces, the hydrogen bonding po, and the ion to dipole forces. Remember that it is a dipole to dipole force in the hydrogen bond, and the types of IMFA are London dispersion forces, hydrogen bonding, and ion dipole forces. Balikan ulit natin yung meaning sa hydrogen bond. It is an attractive force that exists when hydrogen is bonded to the most electronegative atoms, namely fluorine, oxygen, and nitrogen. Kaya kung papansinin po ninyo dyan, ito po siya. Ito po yung examples po natin. We have the water, combination of water and ammonia, hydrogen fluoride, and methanol. Ano pong pinagkaiba ni, kung papansin kasi natin, with the examples of hydrogen bond, naulit lang po yung examples from the covalent bond because lahat ay nonmetals, combination of nonmetals. But if we will differentiate po kasi, in polar covalent bonds, these are intramolecular or within the same molecule, while hydrogen bonds are intermolecular between different molecules. Kaya kung papansinin po ninyo with the water sa first example po natin, kaya bakit siya tinawag na intermolecular? Meron tayong molecule of a water bonded with the another molecule of water. Second example, water is bonded with another molecule of ammonia. Basta again, polar covalent bond, it is intramolecular or within the same molecule, while hydrogen bonds are intermolecular or between different molecules. So, ano po ba ang mas stronger between the two types? Covalent bond po ba? Or polar covalent bond po ba? Or si hydrogen bond? Hindi po porket dalawang molecules of water po yan ang nabond with the hydrogen bonding. Example lang po yun, hindi ibig sabihin nun ay much stronger din po siya kay polar covalent bond. Remember that polar covalent bonds are generally stronger than hydrogen bonds. Again, polar covalent bonds are generally stronger than hydrogen bonds po. So yeah, that ends our discussion about the types of chemical bonding. Wait lang, may nalimutan akong banggitin. If the question is asking for the types of chemical bonds, ang ilalagay po ay ionic bond, covalent bond, metallic bond, and hydrogen bond. But if the question is asking for the two main types of chemical bond, that is ionic bond and covalent bond. Again, ionic bond and covalent bond are the two main types of chemical bond. Kaya in the naming of compounds, yang dalawa po ang gagamitin natin. Set natin. Check natin. Okay, let us test our skill. Determine whether the bonds formed in the following compounds are ionic, polar covalent, or non-polar covalent. Hindi ko po inilagay sa slide yung sasagutin ninyo because it will be part of your quiz. Yes, it will be part of your quiz. Kung kailan ko kayo inimit. So yeah, give me 30 seconds. Pahinga saglit, Tares. No? Let me check first kung okay, let us now proceed to the next topic which is naming compounds. Kaya nga po natin matapos yung kalahati po ng midterm lessons natin para yung kalahati po ay i-discuss ko sa inyo na face-to-face because it will need more, what I mean, it is mostly problem solving po. It involves mathematics. Na alam kong weakness po ninyo. So yeah, wait lang. Okay, we will now continue the discussion about naming compounds. Okay, 20 slides na lang naman. And let us now proceed with naming compounds. In naming compounds po, ang gagamitin lang again natin ay yung two main types of chemical bonding, which is the ionic bond and covalent bond. So magpapangalan lang po tayo ng ionic compound and covalent compound. But first, let us proceed with the role of IUPAC. The role of IUPAC. So IUPAC stands for International Union of Pure and Applied Chemistry. Again, IUPAC stands for International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So IUPAC is responsible for establishing unambiguous and consistent naming systems, also known as nomenclature and terminology. It has a system for naming chemical compounds that provides a standard language for scientists worldwide. Okay, ganito. If the question is asking for um, what provides the standardized rules for naming elements, that is IUPAC. Again, if the question is asking for, it provides the standardized rules for naming elements, that is IUPAC po. So proceed tayo with the next slide. So naming compounds. A chemical formula is an expression showing the elements in a compound and their relative proportions. It contains a combination of chemical symbols and numbers. Don't forget that in compound, balikan po ulit natin ang definition ng compound. I-differentiate po natin sa elements kay compound. Kapag sinabi kasi nating element, nag-iisa lang po ang single atom. When we say compound, it is a combination or a substance containing two or more elements that are chemically bonded. Again, when we say compound, it is a substance containing two or more elements that are chemically bonded. Okay, let us. Kaya kung papansinin po ninyo dito, it is the chemical formula is CO2, which is carbon dioxide po, carbon, carbon and two oxygen atoms. Chemically bonded po siya, kaya tinawag siyang compound. Slide. Naming compounds, carbon dioxide is a compound of carbon and oxygen po. Bakit one carbon atom? Isa lang naman po ang carbon po natin dyan. And the oxygen, the two oxygen atoms because of the subscript 2. Ilan po ba ang oxygen atoms natin dyan? Dalawa. And remember po, subscript po siya and ilalagay sa right after the element symbol po. So sa right po, for example, si oxygen po, ilan po ba ang atom of oxygen dyan? Dalawa. So ilagay po natin subscript niya right after the element symbol. Okay. Let us now proceed with naming ionic compounds. So in naming ionic compounds, an ionic compound is composed of a metal and non-metal, of course, came from ionic bonding. So ionic compound is composed of a metal and non-metal. Some of the basic rules when naming ionic compounds include: first, a metal will always come first in a chemical formula, followed by a non-metal. Again, the first rule, a metal will always come first in a chemical formula, followed by a non-metal. Ano po ba si sodium natin? It is a metal classification. And si chlorine po natin, it is a non-metal in classification po. So metal ang mauna in naming ionic compound. First rule po ay mauna ang metal, isunod si non-metal. kaya sodium chloride. So bakit hindi sir sodium chlorine? Bakit ginawang sodium chloride? Because of the second rule. In second rule, an ionic compound with two elements will have a name that ends with IDE. So yung second rule po natin, kapag ang pinag-combine po natin ay two elements, si sodium, for example, si sodium and si chlorine, yung second element po natin should be ending with IDE. Kaya instead of sodium chlorine, it is sodium chloride. How about this one? It is not copper sulfur. It should be copper sulfide. The second rule, apply natin. It ends with IDE, copper sulfide. So the third rule, in ionic compound, a compound with three elements, including oxygen, will have a name that ends with ATE, ate, or ITE. Okay. So kung i-compare natin dito sa second rule kay third rule, kay second rule po kasi kapag two elements ang pinag-combine, IDE. Pero kapag three elements po ang pinag-combine, including the element oxygen, it should be ending with ATE or ITE po. Sa sodium sulfate po siya. Kaya kung mapansin niyo meron tayong sodium, sulfur, and oxygen. So sir, bakit po, okay, ganito po yan. In the third rule po kasi, pansinin natin, si sodium ay metal, si sulfur ay non-metal, si oxygen ay non-metal. Hiwalay natin ngayon si metal natin, kaya sodium lang siya. Etong dalawang to, it is what we call the polyatomic ion. Again, kapag combination of two elements, it is polyatomic ion. Ito, monatomic ion na po siya. Monatomic ion, polyatomic ion. So sulfate ion po is a polyatomic ion consisting of one sulfur bonded to four oxygen atoms. Again, one sulfur atom bonded to four oxygen atoms. Kaya tinawag siyang polyatomic ion, yung sulfate ion natin. Again, baka i-question na naman ninyo, bakit hindi po sir, sodium, sulfur, oxynate, etc. No. In here po kasi, in the third rule, oxygen is not explicitly named in sodium sulfate. Bakit po? Because it is already part of the sulfate polyatomic ion. Mostly po, or always po pala, always po na ang nangyari ay hindi po pinapangalanan si oxygen because that is part of the polyatomic ion. So we refer to name of the entire ion rather than naming each element individually. So again, siguro i-question na naman niyo for the third rule. Bakit po ATE yan ang ginamit, hindi po ITE? Pwede namang sodium sulfide. Bakit po ginawang sodium sulfate? So, gagamitin natin si ATE. ATE or 8 indicates the oxyanion. Ito pong oxy, wait lang. Okay, so ATE indicates the oxyanion with more oxygen atoms po. Marami po yung oxygen atoms po natin. Apat siya, kaya sulfate. Pero kapag 3 or fewer than the oxygen atoms, for example, kapag tatlo na lang yan, yung oxygen atoms natin, that is sodium sulfide. So kapag for example, si sodium sulfate, it is NaSO4. Pero if it will become sodium sulfite if it is NaSO3. Kapag 3 na po ito. Fewer oxygen atoms. Again, example, pakitake note po. Another example, sinitrate po versus nitrite. Sinitrate po, ibig sabihin mas marami ang oxygen niya as compared to nitrite. So sinitrate po ay NO3 and sinitrite ay NO2. Nitrate, NO3, tatlo po yung oxyanion atoms po niya. And si nitrite, dalawa lang po, fewer po. Kaya ITE ang ending niya. Another example, si phosphate and si phosphite. Si phosphate, ano po bang meron kay phosphate? PO4. PO4. Phosphite po, magbawas lang po or kaya fewer yung oxyanions po niya. So magiging PO3. Basta more ang oxyanion niya, that is ATE, ending with ATE. Pero kapag fewer ang oxyanion po niya, it ends with ITE. Okay po ba tayo dyan? Okay, proceed tayo sa ionic charges po niya. With the ionic charges, ito po ang gagamitin natin. With the group 1, which are the alkali metals, particularly the lithium, sodium, potassium, rubidium, and cesium, ang ionic charge po niyan ay positive 1. Pansinin po ninyo ang periodic table of elements ninyo. Lahat po ng alkali metals natin ay may ionic charge na, may charge na 1, positive 1. So bakit hindi natin isasama si hydrogen and si francium? Kakancel natin si hydrogen because remember that hydrogen in chemical properties, it belongs to halogens po. Kaya kung papansinin po ninyo with the charges of hydrogen, it is both positive 1 and negative 1 because it belongs to in noble gases, in halogens in terms of chemical properties. So bakit hindi sinama si francium? Because of its complicated chemical properties. Hanggang dito lang po tayo with cesium sa ionic bonding. So how about the group 2 elements, particularly the beryllium, magnesium, calcium, strontium, and barium? Check po ulit ninyo ang periodic table of elements ninyo. Charges po niya ay positive 2. Lahat po niyan ay positive 2 except radium, even though positive 2 siya, pero it is not used for ionic bonding. Okay, proceed tayo with the group 13, which is what we call the boron group. With the boron group, ang i-accept lang po natin ay si aluminum, si gallium, si indium, and si thallium. So sir, bakit po hindi natin in-include si boron? Hindi natin in-include si boron. Boron kasi, it may have positive 3 in charge, but remember that boron is a metalloid. Remember that in ionic bonding, it is metal to non-metal, hindi po kasama si metalloid. Metalloid is somewhat used always in covalent bonding po. Mas lalo po natin nakikita yung mga metalloids natin in the covalent bond. Okay, and negative, how about sa group 14 po natin? In group 14, kung papansinin natin with group 14 or the carbon group, iba-iba po sila ng charges and the group 14 po, ito pong carbon group natin, it is mostly used in covalent bonding po. Kaya hindi ko na rin po inilagay diyan. Again, the carbon group or the group 14, it is mostly used in covalent bonding. Nagagamit man sila sa ionic bonding, but mas lalo pong nagagamit in covalent bonding po. Kaya paiba-iba po sila ng charges. Let us proceed with nitrogen group po. With the nitrogen group, if you will see the nitrogen, phosphorus, arsenic, and antimony, lahat po sila yan ay may negative 3 in ionic charges. Lahat po yan ay gagamitin for ionic bonding. Group 16, which are the chalcogens, starting from oxygen, sulfur, to selenium, to tellurium, and polonium, to tellurium only, negative 2 po ang charge niya. That is in ionic bonding po. Even though in the tellurium, positive 2 po ang nilagay po doon. But in ionic bonding, the charge of tellurium is a negative 2. Basta memorize nyo na lang yan. And in the last group, in the halogens po, negative 1. Starting from fluorine to chlorine to bromine or bromine to iodine and astatine. Lahat po yan ay may negative 1 in ionic charges. So yeah, group, ganito lang po yung paakyat po ang ionic charges niya. From positive 1 to positive 2 to positive 3. Then, nag-increase din po siya dyan from negative 1. Nag-increase ng negative 3 to negative 2 to negative 1. Huwag lang po kalimutan yung mga ionic charges natin. So yeah, let us have a simple quiz in ionic charges. So yeah, in ionic charges, I think mas kailangan ko siyang, sige, explain na rin natin dito. But yeah, if you have any question or hindi nyo siya na-gets, the naming or mag-identify ng chemical formula ng ating ionic compound, you can ask it face to face. So yes, let us proceed with magnesium oxide. So in magnesium oxide, ano po ang magiging chemical formula ni magnesium oxide? That is magnesium, MgO. Yan lang po ang magnesium oxide. Kung titignan natin with the charge of the magnesium, it is positive 2, belonging to group 2. And the oxygen, negative 2 po. So instead of magnesium, tapos subscript niya ay 2 Mg, oxygen, 2 rin po dito. Since charges are equal, one magnesium ion combines with one oxide ion. Kaya po ganyan siya. Wala na po yung subscript niya since they are both equal in charges. Magnesium oxide, Mg, tapos capital O, the oxygen. Oxide po, IDE kasi dalawa lang naman po ang pinag-combine natin. Kalimutan, it ends with IDE because there are two elements that are combined. Let us proceed with aluminum sulfide. Aluminum sulfide, ano sa tingin ninyo? What is the chemical formula for aluminum sulfide? So for aluminum sulfide, it is Al, the subscript is 2, tapos sulfur, 3 ang subscript niya. So sir, bakit po naging Al2 tapos S3 po? Pero kung papansinin natin with the ionic charges, si ionic po ay tatlo. Pero with sulfur, meron tayong dalawa, negative 2, positive 3 dito. Pero bakit din sir, naging 2 dito tapos naging 3 dito? Ganito lang po yan. Aluminum forms a positive 3 cation. Alam po natin yan with the use of the charges, the ionic charges. The aluminum forms a positive 3 cation and sulfide forms a negative 2 anion. So, to balance the charges po, kaya bakit naging ganyan? To balance the charges, two aluminum ions combine with 3 sulfide ions, resulting in formula Al2S3. Again, ganito lang po yan, huwag kayong malito. kung ano po ang naging, dito po kasi siya nakalagay diyan, +3 and -2 po diyan. Para maging, balance po ang ating, atoms, 2 aluminum ions two aluminum ions combine with 3 sulfide ions, resulting in formula Al2S3. Okay, let us proceed to another example, which is the potassium nitrate. In potassium nitrate, kung papansinin ninyo, it ends with ATE. So, ang ibig sabihin lang po, it should be 3 atoms po. Ayan po siya. KNO3. So again, may binanggit po ako nung napunta po tayo with the rule number 3. Again, potassium is a metal, kaya nag-isa lang po siya dyan. And si nitrate po, si oxygen, hindi na kailangan pangalanan, hindi na kailangan isa-isahin, individually pangalanan yung bawat elements po. Remember that nitrate ion is a polyatomic ion po. So bakit siya tinawag na nitrate ion? Yung 3 po dyan. Nabanggit ko po kanina, kapag nitrate, again, kapag sinabi nating nitrate, NO3. Pero kapag nitrite, Nitrite, it should be NO2. Again, kapag potassium nitrate, KNO3. 3 po siya dyan. Kapag nitrite, since fewer ang oxygen, oxyanion po niya, magiging KNO2. Okay. Let us proceed with calcium fluoride. With calcium fluoride, madali na lang po siya, pangalanan yan. Since IDE po siya, ending with IDE, ibig sabihin po, dalawa lang po yan. Dalawang atoms lang po, pinag-combine natin with ionic compound, with the compound, I should say. In calcium fluoride, mauna po si metal natin, which is si calcium po. Kaya Ca, since it is fluoride, it is F2. So bakit sir si calcium fluoride instead of Ca as compared dito sa first example natin, magnesium oxide, MgO lang siya. And with calcium fluoride, CaF2, bakit po may 2 na subscript kay fluoride? Balikan natin si ionic charge ng calcium natin and ng fluorine natin. With the calcium here, meron tayong dalawa. And kay fluorine, meron tayong isa. Again, dalawa, +2 cation. And with fluorine, -1 an ion. To balance it, since meron dito siyang +2 and -1 po dyan, to balance it, kailangan po na maglipat tayo. Yun lang yung strategy doon. Calcium is in group 2 po and has 2 valence electrons. Po natin yan. And fluorine has 7 valence electrons po. Kaya, nangangailangan siya or kailangan niya mag-gain ng isang electron to form a negative one. So, two fluoride ions are needed to balance the +2 charge from 1 calcium ion. Ganun lang po yun. Again, +2 po ang charge ni calcium and -1 po ang charge ni fluorine. Gawin natin siyang balanse or maglipat lang po tayo. Gawin natin siyang subscript. Si 1, -1, magiging 1 na lang po siya into subscript. Sa subscript po, hindi po pwedeng -1, +1. It should be a real number or integer po. So yeah, magiging 1 po. Hindi na kailangang ilagay. Alam na natin yan. Sa Ca, 1, ano lang yan? 1 calcium atom lang po yan. And si fluorine, since dalawa po siya dito, lipat lang po tayo para maging balanse. Naging dalawa ang fluorine atoms natin. Calcium fluoride, CaF2. Proceed tayo ngayon sa last example natin. Calcium chloride. Gamitan natin si calcium, calcium, Ca. How about chloride? Balikan natin si chloride. Since chlorine, what I should say, pansinin natin with chlorine, it is with uh, the same group with fluorine, which is they belong to halogens. Same na po ang mangyayari. Ganyan po. CaCl2. Okay po, understood po ba ang naming ionic compounds? Before we proceed with the last one, the naming of covalent compounds. Actually, in naming covalent compounds, it is easier than naming covalent compounds. Is, ano daw? Ibig ko po sabihin, mas madaling magpangalan po ng covalent compounds as compared to naming ionic compounds. Bakit po? Ito po yung mga rules natin for naming covalent compounds. Ano, 21 minutes. Gawin natin siya 1 hour 50 minutes. Okay. So naming covalent compounds, mas madali lang po ito magpangalan ng covalent compounds as compared with ionic compound. Mas madali lang po ito. So in naming covalent compound, of course, a covalent compound has two or more non-metals. Basta kapag ionic compound, it is metal and non-metal. But in covalent compounds, it has two or more non-metals. Palagi po, always po. Lahat po sa covalent compounds ay non-metals only. So some of the general rules when naming covalent compounds are: the first rule, the non-metal farthest to the left on the periodic table comes first. Again, the first rule is the non-metal farthest to the left on the periodic table comes first. For example, carbon dioxide, CO2 po. So kung papansinin ninyo ulit ang periodic table of elements ninyo, ano po ba ang mas malapit sa left? That is carbon. Kaya mauna siya. Basta kung anong pinakamalapit sa left, siya po mauna, in-naming. Yes po. Kasi in-naming, mas mauna po. Basta mauna po. Ano to? So it is because elements in the left side of the periodic table generally have a lower electronegativity compared to those on the right. Kaya kung compare po natin si carbon with oxygen, ano po ba ang electronegativity value ni carbon? That is 2.5. How about oxygen? That is 3.5. So since mas maliit po ang electronegativity or lower po ang electronegativity ni carbon po, siya ang mauunang pangalanan. Kaya carbon dioxide. Actually, in rule number 2, it is just the same with rule number 2 of naming ionic compound. So rule number 2, a covalent compound with two elements will have a name that ends with IDE. Just the same with ionic compound. Kaya instead of carbon carbon oxygen or sulfur oxygen, it is carbon dioxide and sulfur dioxide. So sir, bakit po pwede namang sabing carbon oxide na lang and sulfur oxide? Saan po nakuha yung di and di? It is the application of the rule number 3. In rule number 3, use the prefixes mono, di, tri, tetra to indicate the number of that element in the molecule. Again, in rule number 3, use the prefixes mono, di, tri, tetra to indicate the number of that element in the molecule. Mono is for 1, di is for 2, tri is for 3, and tetra is for 4. Na kung papansinin po ninyo dito, carbon dioxide. Instead of carbon oxide, since dalawa po ang number of element in that molecule po, 2 atoms of oxygen, kaya di. oxide ilagay po sa prefix po niya. Again, sulfur, since dalawa to, sulfur dioxide. How about this last example? Carbon, since apat po to, tetra, since dalawa lang pinag-combine natin, chloride, ITE. Again, carbon, since apat po yan, tetra, chloride. Carbon tetrachloride, sulfur dioxide, carbon dioxide. Okay. So in naming covalent compounds, there are also, remember that many covalent compounds have common names that are widely accepted. For example, the hydrogen. Hindi na po siya pwedeng sabihin dihydrogen oxide, hindi po. Because in naming covalent compounds, some are common names that are widely accepted po. As yung H2O po natin ay tinawag na water. Si ammonia din po, hindi po siya pwedeng sabihin nitrogen etc. Basta ammonia, NH3 po siya, and CH4 po, methane. Hindi po. Basta. Ito pong common names natin that are widely accepted. Ito pong tatlo. Okay, let us have a quiz. Last na po yan. Yes po, slide 50 of 57. Last na po. So yan, let us have a quiz in naming covalent compounds. Proceed tayo with sulfur hexafluoride. Sulfur, bakit po sulfur hexafluoride? So ano pong sagot dapat dyan? That is SF6. So sir, bakit po nauna si sulfur kaysa kay fluorine? Si sulfur, ano po ba ang electronegativity value niya? 2.5. How about fluorine? That is 4.0. Maunang pangalanan po yung pinakamababa ang electronegativity value niya, which is si sulfur. Kaya sulfur hexafluoride po. Bakit din hexa? Hexa stands for 6. Hexafluoride. 6. Sulfur, hexa-6, fluoride, ending with ITE. Let us proceed with dinitrogen monoxide. Di, it means dalawa. So dalawang nitrogen, mono, which means isa, isang oxygen. So ang correct chemical formula for dinitrogen monoxide is N2 po. Dinitrogen monoxide. So sir, bakit po hindi na lang pwedeng dinitrogen oxide? Remember po, dapat pong pangalanan po natin itong second po. Kahit nag-iisa man po ang atom of oxygen natin, pangalanan pa din natin siyang mono. Okay? Dinitrogen monoxide. Okay, let us proceed to the third example. Phosphorus trichloride. Phosphorus, the element symbol is P. Tama ba? P. Phosphorus, P. Tri, ibig sabihin tatlo. Hindi po apat kasi that is tetra. Tri, tatlo. Tatlong chlorine. So PCl3. Phosphorus trichloride ending with IDE. How about glucose? Glucose? Glucose. Pagod na si sir. Okay. How about glucose? In glucose naman kasi, kung papansinin niyo with glucose, ayan po. Balikan natin sinabi doon. Remember that many covalent compounds have common names that are widely accepted. Sige nga, ano po ang correct chemical formula for glucose? Po natin kalimutan. That is C6H12O6. Okay po? C6H12O6. And the last one, silicon dioxide. Silicon, isa lang po, hindi naman sinabing silicon, hindi naman sinabing disilicon, basta silicon, nag-iisa lang. S, dioxide, dalawa. silicon dioxide ending with I. Okay, I think that ends. So, any questions? Any questions regarding the types of chemical bonding and the naming of compounds, both naming of ionic compounds and naming of covalent compounds? If you have any question, you can ask me face to face. Kung ano po ang face-to-face session po natin sa general and inorganic chemistry. Okay, I hope you really understood the lesson. Okay, goodbye. I hope naintindihan po ninyo ng mabuti. Let us end the live video now. Goodbye. Thank you for listening.